I did, namely 2 blocks moving down a track according to a specified position or / velocity profile. So in my other tutorial, I did this thing based on the sketch-based rules. In other words, I created these 2 sketches in the model and used it. Now I want to repeat the same problem, except that I use some kind of script or programming, a simple programming statements in Catia to impose these kind of rules. All right, so I call it formula-based rule. Now, first thing I'm going to do is to assemble this. So there is why don't we anchor first the track? Anchor the track. Okay, then coincident. Let's say this edge and that edge, and coincidence between this plane and that plane, and update. Also, let's move this thing all the way to the back, so coincidence in that edge and this edge, and update, and now deactivate or delete this constraint because we don't need it. Alright, now let's repeat this thing with the other one. So coincidence between that edge and this top edge, and coincidence between this plane and this plane, and finally update and bring this thing all the way to the back, this edge here and that edge, and deactivate this last constraint or delete. Okay, good. So let's see what happens here. Right. We now go to digital mockup, EMU Kinematics, get the magic wand out, and convert these assembly constraints automatically to joints. Auto create. So if you check this, let me hide these constraints. Here we are. If you check the joints, there's going to be 2 prismatic joints as expected, and degree of freedom, of course, is 2. So what we're going to do is we're going to first of all make these things length driven, just so that we have some commands created, which we can later on program them 0 to 21. The reason I put down 0 to 20. The entire length of the track is 21 inches, and the length of each of these blocks is 1 inch, so I make it 20 inches. Now let's make the other one also length driven, 0 to 20. Okay. Needless to say, the degree of freedom is 0 because we imposed those length driven commands or constraints, so we can actually manipulate these 2 manually, and there's 2 sliding bars because there's 2 commands that were made length driven. Now we want to program these things basically. All right, let's see. So the first thing is we go to, if you look at the knowledge toolbar, which is down here, this is where you can specify the formulas, and formulas are going to be simple. You cannot put if statements and things like that. This is where you specify again what is called laws. Okay, these are very simple expressions, so it doesn't apply to us. What we need is rules. The rules we cannot find them here. You have to switch to let's see, knowledgeware and knowledge advisor, and this is where you see rules. Rules basically allows you to write programs, simple programs if you want. So if I click here, it says rule number 1. Why don't I first do the one for the let's see, the blue one. Blue, instead of calling it rule 1, I call it blue rule. Means rule for the blue block, and there is some information here that can be changed when needed. So we say OK, and this thing opens up and basically allows us to write simple programs. Okay, so let's see now. Over here I'm going to say if, and if you, by the way, if you wonder how do you know the syntax, if you go to keywords, you see exactly what is needed here. So if, this is my way of doing it, you don't have to, you can do it any way you want. So let's see now, if time, there we are, this is time, so you can use that. Okay, if time, let me see now, we are doing the one for the blue one. If time is less than 3, position is 0. Okay, so if time is less than 3 seconds, then we have command for blue one, which is, let's see now, that'll be, the blue one is, let's see, this one. Okay, and I put this thing in parentheses. This is equal to 0 inches. Okay, you close that. Hit return. Else, or else if, again, the time, let's get the time here. Now less than 5, right? Less than 5, yep. Less than 5 seconds. Hit return. The command for the position is equal to, I'll put parentheses later on, equal to 2, equal to, let me see, the speed is, let me see now, the speed, if you look at your thing, the speed is 2.5, is equal to 2.5 inch per second, okay, times times parentheses time, time minus 3 seconds. You close it, and you have to non-dimensionalize it. No, actually, that's good. That's good. Don't have to non-dimensionalize, because let's see if it makes sense first of all. So let me close the parentheses here, and then we figure out. All right. So suppose, just hypothetically, suppose that time is 4. Okay, 4 seconds. So what this thing is telling you is that 4 minus 3, let's say time is 3 actually. Time is 3, 3 minus 3, 0, and times the velocity, you're going to get 0. So you're at 0 location. But if the time is 4, then it's going to be 4 minus 3, 1 second, it goes that speed, and you're going to get that end up location 2.5 inches away from the left end. If the time is 5, so it's going to go 5 minus 3 is 2 seconds. 2 seconds, that's going to give you 5 inches, which is exactly where you're supposed to be. All right, good. Now, then we look at the next part. Else, if, parentheses, let's see what the rule is here. If time is less than 9, you stay there basically. So if you say, if time is less than 9, you end up where you were. You stay there. 9 seconds, 9 seconds. Hit return. So we know that the position is actually at that 5-second location, 5-inch location. So if you click here on that command, that's what I want. We want this thing equal to 5 inches. And let's close these parentheses so that it's consistent. Okay, and finally, uh, else, obviously this is after 9 seconds. So that's going to be, for example, I put the command in parentheses. So this thing is equal to, the speed is 15 inch per second, 15 inch per second, and then times, parentheses, time, where's time? Time, minus 9 seconds, and you close the parentheses, and you close the parentheses again. For example, if time is 9, this is 0, so it's going to stay at, well, where it was before, namely 5 inches. 5 inches plus this, okay? So if time is 9, it's going to be at 5 inches, but if it goes, for example, just hypothetically, if it's time is 10, so it's going to be 5 plus 15 is going to be 20, which is where it's supposed to be. I'm assuming there were no syntax errors here, so let's close this thing. Hopefully it'll be okay. Alright, I see that there is some line number 2, there must be some syntax error. Line number 2, let's read this thing carefully. If mechanism, the time is less than 3 seconds, mechanism or the length is equal to 0 inches. That looks good to me. Else, if mechanism is less than 5 seconds, okay, time is less than 5 seconds, so where would that be? We are doing a mistake somewhere. Let's find out. Mechanism, time is less than 3 seconds. The command is equal to 0 inches. Okay, that's good. Else, if this is less than 5 seconds, let's make sure that we did not miss any parentheses. So it's good. I'm beginning to wonder if these things, well, maybe it's okay. I'm not sure. Let me try something else. Let me try this. Instead of parentheses, let me try braces. And although I don't think it matters, but let's give it a try. So braces, like this, and braces. One more time, braces and braces. Right now. Okay, so I think the braces did the job, except that cannot be used in this context. Okay, so parameter S, 9 seconds, so somewhere else. There must be a problem somewhere else. Let's try. I think the braces took care of it, but there is some other issue. Line number 5. Is line number 5? 1, 2, 3, 4, 5. That looks good. That looks good. Oh, here. This should be in braces. I think this should be in braces, probably. Okay. One more time. Must be maybe something else that's wrong here. So braces here. You know what? I have a feeling that this must be 1 second divided by 1 second, and this must be also 1 second. Inch, okay. Nope. Else, if this is less than 9 seconds, there we are. This should be braces. And pray. Yep. Okay, good. So you've got to be careful here. Now let's do one for rule number 2, which is for the green block. Okay, so rule number 2, this should be green block, green rule. All right. Now, by the way, you notice that why I decided to change them from parentheses to braces. If you look at keywords, you see that there are these braces here. So when you write the if statement part is okay, but for the command that you want to, or the stuff that you want to provide, it must be braces by the look of it. Okay, good, good. So let's try. First of all, the other one is okay. So if where the parameters for the mechanism is just time. If parentheses time is less than 2 seconds, you say then the keyword, of course, is going to be braces. Okay, and if you want, you can put a tab here to put it there, no problem. And then for mechanism parameters, okay, so not keywords, parameters, this one, the second one, and we can move that braces later on. Okay, equal to, you look at your drawing, 2.5, velocity is 2.5 inches per second, so it's going to be 2.5 inch divided by 1s. It cannot be divided by s, it has to be divided by 1s. Yep, that's good, that's good. Braces, close it, so right there. Alright, if it's helping you, I'm going to use a tab here to see it better. If it, oops, I think I guess that tab, the tab doesn't work here, so maybe I'll go to the next line, right there. Okay. Else, if parentheses time is less than 5 seconds, so time less than 5 seconds. Okay, hit return. Alright, braces. If you look at your drawing, that position should be maintained 5 inches. So the command is number 2 equal to 5 inches. Close the braces. Else, if parentheses time, okay, less than 10 actually, so I don't need this. Then because I know that the next step is just the last stage, so there's no else. So that guy is equal to the 5 inches that you were already located at, plus parentheses time minus, well actually 10 minus, yeah, not 10, yeah, time minus 9 seconds. You close it, and you close the braces. Hopefully we didn't forget anything. Okay, let's check that. there seems to be some issues with the law. This last law that I wrote, some units probably don't match. Let's go there. Let's see now. If time is less than 2 seconds, command 2 is 2.5 inches times, I forgot the time here, times time. Yeah, I think that's better. Yep, because now inches equal to inches. The other ones I'm pretty sure I did okay. What's the velocity here? I forgot about this. This velocity is actually 3 inches over 1 second. So 3 inches divided by 1s, and then times. The units otherwise they're not consistent. So this is 5 inches plus this should not be 9. This should be actually 5. 5 seconds. 5 seconds. Yeah, so for example, if the time is 10, then this is going to be 5 times 3, 15 plus 5 is 20. That's better. Okay. All right, we're almost done. So now we're going to do simulation with laws. Let me actually create my sensors because eventually I want to check my velocities and things like that. So let me do this one sensor. I'll call this thing the blue one, blue sensor, blue rule. This is the position, blue rule. The reference product is the track, and the point is that corner point. So again, do another one, and I'm going to call this thing the green rule. The reference product is this, and the point is that corner point. Okay, so I've created my sensor that eventually I can plot here. So now we're going to do simulation with laws. One thing I forgot to do is associate these commands with these rules that I created. So let me double click on command 1 and look here. This icon here, it says select your rule. So I'm going to click this, and it's going to pick that rule number 1. Okay. I guess I select that. That's the first one. Blue one. Then I select this. Then I go to the second command. Just the green one. That's the green one. Say OK. Alright, so now we go simulation with laws. Let's do a 10-second simulation. Activate sensor. Let's just plot the Y position of the blue sensor and the Y position of the green sensor. Y vertex, okay. So don't close these things. Play it. There. Alright. So if I plot the graph, I should be getting those curves that I inputted. So here is the blue one. The yellow curve is the blue one. If you compare it, it's exactly what we have there. And this green one is actually the other curve. So we can see speed of 2.5, idle, and speed of 50. So that confirms what we were about to do.